We are going to study
Grammarly does more than catch errors. With Grammarly, you can find really good, no, perfect words that make your writing sharp or explicit or excellent.
The strength of an acid refers to the extent that it dissociates into ions when dissolved in water. Strong acids dissociate nearly completely. Weak acids dissociate very slightly. Dissociation into ions means that when an acid, HA, dissolves in water, it transfers a proton to one of the water's lone electron pairs, and the acid and ion, A-, and a hydronium ion, H3O+, form. The color change of the water oxygen will make it easier to follow in solution later. The key difference between strong and weak acid dissociation is the final concentration of hydronium ion in solution. Since proton transfer from a strong acid to water is nearly complete, the hydronium ion concentration is essentially the same as the original acid concentration. In contrast, proton transfer from a weak acid to water becomes balanced by proton transfer from hydronium ion to A-. So the final hydronium ion concentration is much less than the original acid concentration. Let's view acid dissociation at the molecular level and focus first on strong acids. The concentrated acid in the beaker consists primarily of acid molecules. As soon as they make contact with the water in the flask, proton transfer from HA to H2O occurs for virtually every acid molecule.
Hello everyone. So we would have a lesson very soon. So before we start, I would like to remind you guys to try out this. I would like to check this right away. This question is on page 8. Question 8. So you are going to do this. Okay, and we would love to have a lesson right away. Okay, I'll repeat. Could you please make sure you have finished question 2? All right, all of you are here. So we will start the lesson now. Today's lab, today's lesson, we will go to the spots on the this diagram, and I would like to show you something more about that. Question 2. You are going to have a dilute acid. A, you are going to tell me what is it? What is that? So the clue, where is the clue? What is the acid? What can it be? What can it be?
Dilute sulfuric acid.
How will you know?
Because it's produce zinc sulfate solution.
Yes, we have got sulfate, okay, as the salt, as an anion of the salt. So, which means that the acid should have sulfate ion in the acid. So this is sulfuric acid. Yes, very good. How about B? Guess B. 钟浩俊。钟浩俊。Guess B. So what is the reaction? The reaction between zinc metal with dilute sulfuric acid. So besides having zinc sulfate solution to be formed, what is gas B? Zinc. Now I can give you a hint, right? So zinc plus H2SO4 AQ. So the salt form is zinc sulfate. So what is left behind?
Hydrogen.
Yep, hydrogen. So this is the way to tackle the issue, right? Can you see that? So this is hydrogen gas. So the way to solve is by writing the equations, and this will help you figure out what is that. Okay, how about C? Lê Kiên Hậu. Now use the same tricks. So you know what's the short form?
Instead,
So what is left behind?
carbon dioxide and water.
Yep.
So the gas is carbon dioxide.
Yes, that's right. So this is the way to solve the problem. Can you get my point? So this is how we deal with those gases, right? Both they are colorless gas, but one of them is hydrogen gas, the other one is carbon dioxide. So it depends on the chemicals we are looking for. If it is metal itself, when we react with dilute acid, the gas is hydrogen, while the metal carbonate is a reactant. If that is the case, the gas form is carbon dioxide, irrespective of any type of dilute acid we use. Of course, there is one exception. Dilute nitric acid, you need to be highly aware of the final product because it's very strange. A very strange case, very strange example. Now, how about D? 先進期. How about D? What is the type of reaction between sodium hydroxide and sulfuric acid? So what is the salt form? Yeah, then you do the same tricks, right? X, we have done it here. How about this? So what is the salt?
NaSO4.
NaSO4. NaSO4. Agree? Nearly correct, but you have to take a look on the formula. It is Na2SO4. So because sodium ion is 1 + 1 charge, sulfate ion is 2- charge. Okay, you are going to balance the charge. So leaving behind is H2O. So the answer is sodium sulfate solution. You just give the name, right? How about black solid D? E. I add together to form blue solution F. 有人中意? What can it be? What is the black solid? Once we react with acid, they will form blue solution. I give you a hint, it's an oxide. It's a metal oxide.
Copper dioxide.
Yes, copper dioxide. Now, if I have a copper dioxide, now you should be highly aware of the description of the solid. It's black solid, it's copper dioxide, and reacts with sulfuric acid. So similar to what you have for the other reaction. Okay, can you see that? So you do the same tricks and you may get this is the copper 2 sulfate AQ together with what? Can you see that? It is H2O. So the blue solution here, it is copper 2 sulfate solution. So the solution is blue. Okay, why? Because we have got this ion in aqueous medium, which is blue. Okay, is that clear? So how about gas B? You are going to suggest a test for that. How you do this? Gas B, how you give the test for that? Of course, I can answer. I can ask you a question for gas C, right? For example. So just have a try first. How you test the presence of gas B?
Put a burning plate near the mouth of the test tube that containing the gas B.
What splint? What splint?
Burning.
What burning splint? Put a burning splint, and then the mouth of a test tube containing the gas. Expect observation, please.
It will produce a pop sound.
Yes, good. Okay, a pop sound will be heard, which means the gas is hydrogen. Okay, is that clear? So you have got this a very authentic way of expressing the test of the gas. Of course, I would do the same by asking you carbon dioxide, right? You bubble the gas into lime water and try to check if the colorless lime water turns milky. You understand? So this is what you know about this. Any questions so far? Now, and last time we also done that, right? To get to know the name of the salt. The name of the salt comes from two parts, right? One from in the metal part, the other one, the non-metal part or anion part, comes from the acid. Okay, so leaving behind is the chemical you're looking for, just like hydrogen gas or carbon dioxide and water, or simply water. Now it depends on the type of reaction. Okay, any questions? Now, if not, I would like to show you this one, the role of the water in exhibiting properties of an acid. So, you are going to watch a video talking about this one. Pure acid is some pure acid may be solid, not just like having a very large molecular mass acid, just like citric acid or salicylic acid, and some of them they are like quite just like sulfuric acid, nitric acid, ethanoic acid, and gases. It's just the hydrogen chloride. Now, very strange name. Hydrogen chloride is a gas, but once I dissolve in water, we call that hydrochloric acid. So it gives different naming. While you write down the different stage, it gives a different meaning. So we would like to show you a video about citric acid as example, and we'll show you the characteristics of an acid that would be try to see if it's dry or dissolved in water. What is the action on that three? Okay, blue litmus paper, magnesium ribbon, sodium carbonate. So take a look on that. Try to see if you can listen to it.
Going to
Can
study
you see
the
that?
role
I
of
can listen
water.
to it.
Yes, yes, yes.
Yes, yes.
Yep, you can listen, right? Just I continue. Yeah, what happened?
Put a piece of dry blue litmus paper into citric acid crystals. No color change is observed.
I would like to some of the chemistry of the reaction between acid on dry blue paper, magnesium ribbon, and sodium carbonate. Now, so what is the difference in the observation while you talk about without water and with the presence of water? What is the difference between them? So you may see these, okay? So you may have the dry blue litmus paper remains blue in the citric acid crystal, while you would have a aqueous solution of citric acid, which means like with a water added, and it returns red. Magnesium ribbon, no reaction on crystals, but if I put it in an aqueous solution of citric acid, there is efflorescence. Similar case, but you see it as sodium carbonate. Okay, you all see that. So what is the conclusion? What is the conclusion after watching this? What's the conclusion? Siwaki, what is the conclusion?
What need to present to show the property of the acids?
Under what situation will an acid would exhibit its acidic property?
With the presence of water.
Yes, water must be present. So underline the term. Water must be present for an acid to exhibit its typical property. So water plays a very important role. But here comes the question. For the acid solid or acid in aqueous solution, those hydrogen ion are found inside, isn't it? How come we have got the acidic property being exhibited while it is in water? So indeed, in order to get to know what is that, it's time to take a look on the word, take a look on the structure of citric acid. Citric acid. Citric acid, could you please search on the web, what is the formula and what is the structure of citric acid? Now, I give you about 30 seconds. All of you, could you please type on the web, check for me. What is said to be citric acid? So what is the structure? Do you know? Citric acid. Do you all find it? Just type citric acid and then structure. Okay, citric acid structure. Yes, it's not a structure. Someone has given the answer C6H07, but it's not a structure. I need a structure. What is that in a structure? So the structure, it's something like this. All of you, could you please mark it here? CCH, C double bond OOH, OH here, and then C double bond OOH, and this one, similar to carbon 1, we've got C double bond OOH, right? So this is what we call it as citric acid. So this molecule is very special. Without it is just a molecule, right? How we know it's a molecule? Well, they are just connected by, is bonded by covalent bond. Okay, of course, hydrogen ions will not be formed. However, once it's dissolved in water, we have got a process, we call that dissociation or ionization. In particular, if you want to talk about a process in which a molecule turns to ions, we will call ionization. Okay, how this happens for citric acid. by dissolving water to form hydrogen ion and citrate ion. So what is citrate ion? Citrate ion, we have got the structure like this. Very similar to the structure of citric acid. But the formula it is COO minus, COO minus. Have you ever checked it on the web? COO minus. So, which means that once the molecule dissolves in water, not all hydrogen atom will be ionized to form hydrogen ion. Instead, we look for a very typical groups of atoms. Tell me which groups of atoms it is. What is that group of atoms? Okay, for those who know it, just type the chat box and just say aloud in the mic. Whenever it meets a groups of atoms, right? So here comes a dissociation or ionization of the acid. What is that? I'll give you another case. You may find that difficult, right? So could you please type for me the structure of the term ethanoic acid? And this is the chemical found in vinegar. Ethanoic acid, ETHANOIC, ethanoic. You soon with 2 carbon. What is the structure? What is the structure? It is what? CH3
COOH.
Yep, COH. Once it undergo ionization, what will happen? It will form what? It will form what? CH3. Could you please type the word ionization next to the word ethanoic acid? So what is the equation? You find it on the web. What is that? CH3 CH3COOH, okay? That's right, CH3COOH and H3O plus. So what are they in common? Is that whenever you have got an COOH here, that H here will undergo ionization to form its salt form, okay? While I release hydrogen ion. So we call that process ionization, okay? Remember, but not other hydrogen. Now, remember this is just for organic acid. However, if you want to talk about as hydrogen ions found inside an HCl, for example, HCl we don't have any COOH, right? But it also dissolve in water and they will ionize. So what does it mean by ionization? I tell it again, it is the process in which it turns from molecule to form separate ions. Can you see that? Separate ions. So we will call that ionization. So this only happens when there is the presence of water. So remember, go back to the question number 1. If you want to have the acid show its acidic property, remember to have hydrogen ions. Believe it or not, you may have the similar equations found in sulfuric acid as well and nitric acid. While you may have the sulfuric acid, the hydrogen ions will be released together with sulfate ion, while for nitric acid, also we have got hydrogen ion together with nitrate ion. So again, it is a process. We call it as ionization. Any questions so far? So somebody will say that acid is just a covalent compound. Yes, that's right. No matter what form it is, no matter what physical state it is, it's still a covalent compound. And it will produce hydrogen ion as only positive ion. Do you see the word only? Only positive ion when dissolved in water. Actually, it's not produces, we call that ionize. Ionizes. Okay, so the covalent compound, which is in form of a molecule, it would produce, it will cause the formation of ions. Of course, you may find it very strange. Okay, so molecular form, it is of no charge, but once it forms ion, it has charge. So that's why it will help you explain for the electrical conductivity of acid when it is in dilute. Okay, when it's dilute, for dilute acid, why does it conduct electricity? And here comes the reason. It's because you said it's because of mobile ion, right? Isn't it? While the mobile ions is caused by what? Ionization of acid. Okay, so far, do we have any questions on that? For those who don't understand what I just said, could you please put a cross into your chat box? And for those who understand what I've just said, simply put a tag. Just one tag only. Now, which means quite a number of you are not inside the lesson. How about the others? 曾浩正係咩啫你？
我剔啊，但係我唔知點撳啊。
哦，你剔但唔知點撳？
係啊，邊度啊？
All right， 有冇人幫到佢啊？識啦，歐浩軒都識撳啦。
仲揾緊啊？
仲揾緊。麥建陽咧？鍾浩俊咧？
喺回應嗰度撳啊。
係啦，咁你見到噶嘛？係咪啊？我爭你啫喎。見到啊？我有隻豬都寫到啦。歐浩軒俾隻豬嚟喎。All right， so 有啲人明，有啲人唔明，係咪？即係咩意思啊？你唔明嗰一樣嘢係咩？即係個 ionization 係嘛？ So I would like to show you the video, right? For example, you should search on the web. Try to see what will you find. If you search on the web on the term ionization, animation. So what will you get? Okay, just search ionization of acid. So we call that animation. So try to see what you can have. Can you see that? So I would like to click this. You may either take a look on the equations on that, for example. Now to have a recap first of all. Now take a look on this. What is that? It is the ionization of one acid. What's acid? Acid it is ethanoic acid, 醋酸. So once while the smaller molecule on the left hand side, what is that? What's the left hand side? Right hand side. This is a more water. So you will see the irreversible sign, right? That irreversible sign is something wrong. So the top arrow should be pointing towards right hand side, while the bottom arrow it should be pointing to the left hand side. Also, all thing is has been reversed. To form, take a look on the right hand side. What's that? The bigger molecule. It is CH3COO minus. Can you see that? While on the right hand side with the one more green dot going to water. So what is that? Can you describe what is that? Take a look on page 11. What is it? We will call it as hydronium ion. Take a look. Hydronium ion. So in dative covalent bond, you have heard of this term before. So why is it the dative covalent bond is that the hydrogen ion here, okay, we have got the covalent bond in between the lone pair electrons of oxygen atom to the hydrogen ion. So the we call it hydronium ion or hydroxonium ion, and simply because the hydrogen ion being too small and too reactive, so they will combine with the water molecule to form such a more stable species. So whenever you talk about hydrogen ion being exhibiting exhibit property, you may also see on the web that that two concepts is interchanged. The concept of it is interchanged. Hydrogen ion and hydronium ion, whenever I see such, that means we have got acid. Well, we have got these ions and they will cause a chemical reaction. So you take a look on the animations. You take a look at animations here. So you take a look on this acid ionization. So what happens during the process? Take a look.
Acid ionization in water is an equilibrium reaction. Acetic acid ionizes in water to a small degree, forming
Again, the equation, the equation is not written so well, so be aware of it. Okay, so the equation, the arrow, right? The direction arrow, please take note of that, is wrong.
and acetate ions. Because of the small degree of ionization and because water is nearly a pure liquid, we rearrange the equilibrium constant expression. If we now remove water from both the chemical and equilibrium equations, we get the acid ionization constant for water. The Ka for acetic acid is 1.7 times 10 to the minus 5. The animation sequence shows acetic acid reacting with water to form hydronium and acetate ion.
Now, this is the equation. This is the process. Now, don't worry too much about the mathematics, okay? You will know it later, but not in Form 4. But you take a look on this action again. So what happened to it? Take a look. First of all, recall the acetic acid, ethanoic acid, C3COOH. Can you see that? The black ball is carbon. The red ball is oxygen. How about the white ball, the smaller ball? This hydrogen. Can you see that? CH3COOH. Water is H2O. What will happen when these two chemicals meet?
Acetic acid reacting with water to form.
It seems like the acetic acid, the ethanoic acid, loses its hydrogen ion, while the hydrogen ion is now get the dative covalent bond with water, so to form hydronium ion. How do we call this process? Before that, both they are molecule, right? After that, what is that? One of them is CH3COOH, negative charge. The other one is H3O plus, positive charge. It forms an ion. So we will call that process ionization.
Hydronium and acetate ions.
Okay, get my point.
At equilibrium, both the forward and reverse reactions proceed at the same rate, such that the net concentration of each ion remains constant.
Do you understand? Do you understand? So here comes the formation of ions from a molecule we call the ionization. So we'll take a look on that. Class practice 14.2. A student mix solid sodium carbonate with oxalic powder and then water to mixture. What do we expect to observe? What do you expect to observe? Mr. Lam? Okay. Hello, Mr. Lam, where are you? Lâm Hiểu Phong. Hello. Hello.
Colorless gas is produced.
What is that colorless gas?
Carbon dioxide.
Carbon dioxide, yes. But explain. So you are going to tell me in detail what happens when water is added. What happened? The oxalic acid dissolves, and what you call that process? Ionizes to produce what? Hydrogen ion, or you use the word hydronium ion. Hydrogen ion or hydronium ion, they are responsible for what? The typical properties of an acid. So, which means that when reacting with sodium carbonate, it gives CO2 gas, which is colorless. Okay, so you are going to match the colorless gas to the formation of CO2 gas. You know that it is an acid, reacts with the sodium carbonate. But why would he have such a reaction? Most important term, ionization, right? The oxalic acid to dissolve and ionize, and water and ionize to produce hydrogen ion. Do you understand?
Yes.
Yeah. Nice. Anyone who don't know what is happening, let me know now. Let me know now. Anyone who still don't know what's that? Now, during pandemic times, you guys have done that experiments nearly daily. Now, to me, even though I'm not in chemistry lab, we do this experiment daily. Very similar type of reaction. Could you please tell me where, under what occasion, if I do the experiment, even though I work at home, I can still do this similar reaction? How? Cooking. How? Cooking, I produce CO2. Hey, come on. Oh, nothing. Anyone who can tell? No, no idea. No idea. Now I give you a hint. Go to the web and type the word Hong Koi Si. Do you know what's that? Type it now. Type it now. Yes, Hong Koi Si. during pandemic time, you need to keep yourself healthy, right? By drinking such, right? So what is that? 慷慨先. You don't know what's that? Really? You don't have such experience? Yes. What happened to this? What happens to this? 慷慨先. Không khỏi si. Don't tell me that you don't know. Yes, that's right. So what is that about? Right, you'll give you a very simple down. So what is that?
Ew. 想骨骼強健，咁樣撒點得㗎？飲康鈣斯，日日補充絲加鈣，提升抵抗力，仲強化骨骼。每日一撒好健康，康鈣斯。
Don't tell me that you don't have it before. It's your turn. Tell me what is the principle of this tablet? What is that tablet? You call that Basicity tablet. What is the working principle of this FIZZY Basicity tablet? 何小雲, don't tell me that you don't know what is that. I just give you something in which it seems to be more familiar to you.
中文係咩啊？頭先嗰個
慷慨先，個詩字就冇辦法譯到俾你啦。慷慨咁就係中文嚟嘅。What is the principle of 慷慨先 ？Tell me.
Clemency.
So what is that? 慷慨先 Do you see that? You type it on the web or you find this at home. Yes, but it's just dissolved. How come it gives out gas? So what is that gas? You don't understand what I mean? 明唔明啊？
佢
沙沙聲會出嗰啲 gas。
Yes, you have to search. Tell me what makes that gas. It's time to type on the web. Tell me, what is that inside? You have active ingredient inside? Yes, that's right. So you take a look on that. Baby Kingdom, so scary. This one. So what is the active ingredient? Take a look. Any chemical that will help you explain. Take a look. Sodium carbonate will react with vitamin C acid. So what is that? Vitamin C acid. What's that? Take a look. Take a look. What can it be? Vitamin C, which means what acid? Sodium carbonate. Is it sodium carbonate? Take a look on the active ingredient. No, it is sodium hydrogen carbonate. Can you see that? What else? What is acid? Acidity regulator, of course, you don't know what's that, okay? But vitamin C, you know what's that? And also, what is vitamin C? Vitamin C.
It's used to protect our gums.
So what is that in chemistry? What is that? What is the chemical? What is the chemical formula of vitamin C?
C6H8O6.
So what is that? Tell me, what is that? vitamin C.
Ascorbic acid.
Yes, ascorbic acid, which means an acid again. It is an acid again. Ascorbic acid. Ascorbic acid.
中文叫嗰個乜嘢抗壞血酸係乜嘢？
即係咩㗎 ？Ascorbic acid. You take a look on this ascorbic acid. It's vitamin C. Can you see that? 抗壞血酸. It is the use of that acid. But it should help prevent lean gum, prevent scurvy, right? According to biology, right? Biology knowledge. So it is a type. You use it to be good to your immune system, right? For those who want to have good health, prevention from flu, right? You need vitamin C. Do you still remember? So it is a water-soluble vitamin. Why is it water-soluble? Because of the formula. It's ascorbic acid. So this one, it is the chemical. So once it dissolves in water, what will happen? So it will produce what? Ascorbic acid dissolved in water. Dissolve in water to produce hydrogen ion. So we call that ionization. While this will react with sodium hydrogen carbonate to form CO2. So that's why the fizzy tablet will cause effervescence in water. And so that's why the ascorbic acid, have you ever bought this? It is in a sealed plastic bottle inside. Okay, while in the points to note, it's always said that you have to keep it into a cool, dry place. You know the reason why, right? It's stored in a cool, dry place. Do you understand? Now, 明唔明呢個發生咩事? So this is what you know it about fizzy tablet. Any questions so far? So, Mr. Chin, you want to tell me something very nasty, right? So you need to know some 14.4. I would like to do it finally, but it comes to our concern about this structure because for ethanoic acid, what Mr. Chin has suggested that not all hydrogen ions is ionized, right? Hydrogen atoms are ionized. Only this hydrogen atoms in that COH group will that be ionized. So we would call ethanoic acid one per molecule, they would produce one hydrogen ions. So we call that acid monobasic acid. Okay, mono means one, monobasic acid. So you may have heard of this term basicity, 鹽基度, which will tell you the maximum number of hydrogen ions that can be ionized by one molecule of an acid. So take a look on the word one molecule of acid molecule, how many hydrogen ions can be produced. So each different acid, they will have different basicity. For example, HCl, hydrochloric acid, its basicity is 1. Ethanoic acid, even though I've got 4 hydrogen atoms in the molecule, found inside in one molecule, is also basicity 1. How about this? But for if you want to talk about H2SO4, it's a dibasic acid because each H2SO4 molecule will produces 2. Can you see that? It produces 2 hydrogen ion. While phosphoric acid 磷酸, we call it as a tribasic acid because once it dissolves in water, here comes 3 hydrogen ions per molecule. So you may see that one. Now, usually, for mineral acid, the number of hydrogen atom found inside in the acid in the formula, they will directly show you the basicity. Can you see that? This is mineral acid. and this weak acid. And for this, if you want to talk about the organic acid, the basicity, you have to check COOH. Do you understand? Not all hydrogen atoms found inside is said to be ionized. How about this? Tartaric acid. Another acid, right? Don't get worried, but you may see where is that COOH, right? What is the basicity of tartaric acid? Wang Qinghua, what is the basicity of tartaric acid? What is that tartaric acid? Tartaric acid, we call it 沼石酸. Yeah, it is commonly found in grapes. So what is the basicity of this tartaric acid? Start with, you are going to check what. First of all, is the organic acid, as I said to you, is from grapes. 提子. So whenever you talk about an organic acid, you are going to check what group? COOH. Take a look. Where when you find COOH? In the molecule. How many COOH group can be found? Generally, how many groups of COOH can?
COOH.
Yes, COOH. Of course,
Three.
what? 3? Can you locate for me which 3?
The left.
The left one, left hand side. What else?
The right hand side.
The far most right hand side. What? Where is it?
Only 2.
Yes, we have got only 2. So the ionizable hydrogen atom is inside the COOH group. So where is it? Here, and also here. So the basicity of the acid is 2, which means that this acid is a dibasic acid. Can you get my point? It's dibasic acid. Questions? Easy, right? So you take a look on this. Finally, if you are going to write down the ionic equations, okay, or it will help you better understand what really happens in the reaction. Now, for example, just like last time while you do displacement reaction, you talk about the ionic equation. It simply is done by kicking out the spectator ion. In this case, if you have got Mg and HCl to react with form magnesium chloride and hydrogen gas, so chloride ion is a spectator ion. So this is the ionic equation. This is the one. Remember, you are going to show the following: Mg1, hydrogen 2, but for the overall charge on both sides, it is +2. You are going to balance the charge as well. So it is not just Mg and H plus and Mg2 plus and H2. You are going to take into consideration the total charge as well. What will happen if I'm going to write down the ionic equation for sodium hydrogen complex solution together with dilute sulfuric acid? Well, similar tricks. So you may find this is the ionic equation. while I have kicked out what? I've kicked out some spectator ion, no? Okay, so tell me what are the spectator ions? What are the spectator ions? What are the spectator ions? Nain, where are you? For this equation, what are the spectator ions? Anyone who can help? What are the spectator ions?
Sodium. Sodium.
Sodium ion and
Sulfate.
sulfate ion. Yes, that's right. Sulfate ion can be crossed out. And sodium ion can also be crossed out. So leaving behind is two hydrogen carbonate, 2 hydrogen ion, 2 water, and 2 carbon dioxide. Very strange, isn't it? Right? 2, 2, 2, 2. So you are going to simplify it by writing down 1, 1, 1, 1. Your turn. Could you please transcribe the following chemical equations into ionic equations? The first one. What are the spectator ions? What are the spectator ions? What are spectator ions?
Iron.
Iron is a spectator ion, can be kicked out. Agree? Now recall your memory on doing ionic equation. Under what situation can we cancel the both spectator ion on both sides? First of all, they must be the same. Now take a look at these. Are they the same? Iron and iron 2 sulfate in iron in iron 2 sulfate AQ, are they the same? Now this one, if I split it into two, what is that? We call it Fe2 plus AQ and sulfate ion. Now only those which is AQ can be split. While my question comes, Fe solid and Fe2 plus AQ, are they the same? Are they the same? Are they the same? Are they the same? No, they are not the same. What is the difference? Iron solid is just an element, while iron 2 ion, the whole thing is a compound. So iron 2 ion is just a part of the compound, part of the ionic compound, right? They are not the same. Not the same. So remember, for this type of the equations, you are going to check for the AQ first of all. Only by having AQ can the ions can be split. So the answer is what? Fe solid plus what? 2 hydrogen ion to form Fe2 plus and hydrogen gas. Do you understand? So remember, this one it is just 2, which means the mole ratio. Indeed, it is hydrogen ion and sulfate ion in 2:1 ratio. So you are going to present it as 2H plus. You're going to show it as 2H plus instead of H22 plus. It's not correct. Okay. Questions? 歐浩軒直錄on B. Could you please tell me the equations? Ionic equations. Any spectator?
Calcium ion.
Calcium ion is a spectator. Agree?
No.
No. Why not? Are they identical? Are they exactly the same? Now, this time is another case. Calcium carbonate, the calcium ion inside is calcium ion, of course, right? But for calcium chloride, the calcium ion is still calcium ion, but they are not the same. Why? Because the calcium carbonate, the ions, the both cation and anions found inside, they are not mobile. But for calcium chloride AQ, the both calcium ion and chloride ion, they are said to be mobile. So this cannot be further split. So whenever there is a reaction, this will react all together. Could you please tell me, could you please get what I mean? So that's why when indeed for the ionic equation, which will tell you how those reactive species react. While for those spectator ion, they are just passerby. They just watch. They just watch over they just watch the competition. Okay, but they will not take part in it. So calcium ion found inside solid is very special. So they are forced to take part in it. But finally, if you check that charge, it is still 2+. So calcium carbonate is forced to be here. So do you mean that whenever you talk about ionic equation, you have to split the AQ? Yes, that's right. Only split those in AQ. So the answer is calcium carbonate plus 2 hydrogen ion to form calcium ion AQ plus CO2 AQ gas and water. Do you understand? So what are they in common? Is that whenever what acid you are going to have, they share the common ion, hydrogen ion. Okay. How about question 2? Effervescence occurs when a few drops of lemon juice they are added to sodium carbonate powder. Write down the equation for the reaction involved. So again, sodium carbonate powder. So it is sodium carbonate powder ion equation. Whatever acid it is, lemon juice. We have got so many acids. One of them is citric acid, ascorbic acid, etc. So don't worry too much about the nature of the acid. Whatever acid it is, it shares the common ion. What is that? What is the common ion?
Hydrogen ion.
Yes, hydrogen ion. Again, and again. Okay? To form what? To Na plus, and then what? CO2, and finally H2O. So this is the ionic equation. Do you understand? Do you understand? So, we would love to, in today's lecture, we come up with the ionization of acid, because it will help you better explain why water will play a very important role in showing the acidic property of acid. Without water, acid is not an acid. Wow, so philosophical, isn't it? Right? For a solid acid, it's not an acid because it doesn't perform like an acid, even though it's named as the term acid, only by dissolving water and ionized. Do they produce hydrogen ion? While hydrogen ion is the chemical species which cause the chemical reaction. So in the Ionic equation, you would just write down hydrogen ion, no matter what acid it is, right? H2SO4 hydrogen ion, HCl hydrogen ion, citric acid hydrogen ion, ascorbic acid hydrogen ion. So I need water for help. Okay, and finally, we will come up with the term basicity, right? While you talk about this. Any questions so far?
Mr. Chin，
Yes.
咁我想問，如果 acid 後面寫住嗰個 solid state，咁算唔算 acid？
Solid state.
You
can answer. Anyone can help. If I write down ascorbic acid and then write down a solid, would they have any reaction? Now, for example, citric acid solid. So I just write down citric acid solid. So the name is still called an acid, but it doesn't have any acidic property because no water. Now, so how would you verify this spot? Is by checking its property here, right? Without water, it will not turn blue litmus paper red. It will not react with magnesium, and neither does it react with sodium carbonate. So this is what I would like to share with you today. Any questions so far? No? Ray, no? Now, to end up the lecture today, I would like you guys to have a try on the structure type questions. Question 14 on page 40. So it seems that quite a number of you found it problematic around to balance the equation, right? No matter it's full equation or Ionic equation. So since time is running short, I cannot finish all of you with you, but let's try the first one and leaving the other three by yourself and do it at home. So question 14. For each of the following experiments involving acid, state the expected observations. Number 1, 2, write a chemical equation, and number 3, Galileo, and write an Ionic equation for me. Okay, I need that 3. I pick up the first one as example, and could you please do it the remaining by yourself? Take a look on the first one. Zinc is added to dilute hydrochloric acid. So what is the observation?
gas bubble produced.
Yes, gas bubbles, they are given off. What is the color of the gas bubbles? You still need to tell. Colorless gas bubbles are given off. Number 2. What is the full equation? Of course, you may say you may also say it as zinc dissolves. Is also okay. How about the equation? Zinc reacts with HCl to form zinc chloride and hydrogen gas. How about Ionic equation? As said before, no matter what acid it is, what is the ion? That should be shown.
2H+.
Yes, still hydrogen ion to form zinc 2+ and hydrogen gas. So this is the Ionic equation. Can you manage? Could you please do that? B, C, and D. Okay. Could you please do that? B, C, and D. at home, and I would like to share with you on this. Any questions so far? Can you manage to do this? Tell me 2 questions. Number 1, is the level understanding. Number 2, what find it difficult to you? You have to tell me answer 2 questions. What finds it difficult to you? If you find that there's no difficulties, just type NA or new. To the whole lesson. 0 to 10. And what are the difficult part to you? Two answers. Can you just give me one? What is the difficult part in your eyes? Basicity, ionization. Let me know. Let me know what you have shown. 5 ionize, ionize, basicity, 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 basicity. 5 ionization, basicity, ionize, basicity, basicity, basicity. All right. So 2 points: ionization and basicity. Yeah. So ionization. Anyone who can tell? Anyone who know the meaning of basicity? Show it here. Basicity and ionization, right? You just tell. Ionization. The means what? Means what? Means this, right? Ionization is the process of turning the molecules to ions. So the process, we call that ionization. And this happens in most of the acid. Okay, of course, some acid, they will have 100% ionization, while some of them is not. That's why we will call some acid a strong acid and some acid is a weak acid. Okay, point number 1. Why would they have such a triggering of ionization? Is that what? The water, we have got a lone pair electrons, and being negative, okay, they will attract towards the H atom from the acid. Okay, so just like this. Now take a look on this. Is delta minus, is delta plus. While water, we have got delta minus, it will attract towards this one, and it will help pull away the hydrogen atom to form hydrogen ion. By doing so, you may have got chloride ion left behind, and we have got a very strange structure. We call that hydronium ion. So this is the process, and that is why it will be like that. And this will help also explain in the basicity of organic acid. Why? The basicity of organic acids, they will happen for organic acid on where? On the place where you have got COOH, but not CH. Why? Again, you take a look on the word electronegativity. So because of the fact that most of the electrons, they are now condensed towards here, okay, it seems like a pulling force which will drive the bonding electrons. The bonding electrons is now driven towards the side on oxygen. So leaving behind, it seems like this hydrogen atom will cause will lose the electrons. They will form hydrogen ion so easily. Okay, that this part will be less easily occurred while you having this hydrogen. Why is it not so ionizable? It's because you check the electronegativity. It is a very slight change in this electronegativity. So the formation of hydrogen ion is less readily made. So for CH bond, that bond is a very slightly polar, but this time hydrogen sorry, I write wrongly. It is on here. It is also plus, but this one is minus. I mark it down. It is minus, plus, but this part, check the electronegativity, a very small difference only. Okay, a very small difference in electronegativity. How you check the number? Check number. Electronegativity. Electronegativity. You take a look on this. You take a look on this. Can you see the trend? Can you see the trend here? So you may find the O and H. Take a look on H. H is 2.1. O is 3.5. So the larger the number, which means that the more slightly negative charge it can be. So very large difference, right? Of 1.4 difference in electronegativity. How about H and C? C is negative, right? H is still positive, but C is 2.5, H is 2.1. So the difference is just 0.4, which means that this covalent bond is very slightly polar. Okay, the pulling force in between the two, in between the bonding electrons towards the carbon is rather weak. In other words, those hydrogen atoms will not be easily ionized when you compare with the hydrogen atom directly attached to O. 2.1、2.5、3.5，知唔知我講乜
？Mr. Chin，Mr. Chin，
係。
如果個2.2嘅話，咁減埋咪就0咯，咁即係點？
咁如果0嘅話，咁係咩意思啊？就係即係咩意思啊？
冇得 ionize。
唔容易，應該話如果個指數細 delta En 啊 electronegativity 電負性係越細嘅話，意味住咩咧？呢個 covalent bond 嗰個 bond 個 sharing of electrons 係唔係好勢均力敵？即係個指數差唔多，即係好似 it seems like 7個波扯大纜咁啫嘛，係嘛？咁就係話俾你哋聽個 bonding electrons 大家都即係大家掹嘅能力係差唔多，咁即係話俾你聽咧，到最後。嗱，永遠都係細嘅數，嗰啲電嗰度嗰個 atom 啲 sharing electrons 咧係俾人哋掹走嘅，咁啊細嘅數字就俾人掹走嘅。但係如果佢對面嗰個數咧同佢勢均力敵嘅話，咁其實所謂嘅掹走贏人少少啫嘛。咁即係話嗰粒電子 bonding 嗰粒電子係咪唔容易俾佢啊？即係所以咧，你見到 CH 嗰度咧係唔容易有 bonding electrons 係成嚿甩嘅。嗱，永遠咧個 H atom 係完全地甩咗嗰個 hydrogen 電子，咁就叫 hydrogen ion 啫嘛，係嘛？咁我做唔到啦，得唔得？咁但係呢個咧就做到啊，因為咧佢哋好勢均力敵啊，即係呢個係強弱懸殊啊。咁即係話佢哋嗰個 bonding electrons 大部分係扯咗去邊啊？扯咗去好似係 O 嗰邊係嘛？扯咗去 O 嗰邊。 咁即 H 咧好似就係冇甩，好似冇咗電子咁啦。咁喺水入邊咧就啱晒啦。咁水會點啊？水咧佢哋會有 water molecule 嘛 ，water molecule 咪有啲負嘅，呢個係正啊嘛。咁呢個負嘅位咁點咧？佢就會撞埋去呢個 H 嗰度，就引發到呢個 H 咧就唔中意黐呢個 O 啦，就反而佢中意黐水嗰個 O。咁我嗌呢個現象咧就叫做 ionization 啦，得唔得？而會發生呢件事嘅位係邊咧？就係 COOH 個位。如果係有機酸嚟講 ，COOH 個位係最容易會甩嗰個 H atom 變成 H ion 嘅 Hydronium H plus 嘅 ion 嘅，得嘛？所以我咪一開始
get 到少少，
係啦，咁所以咪叫你 check 咯呢一度。又問你鹽基度啊嘛，咁鹽基度一定要講緊佢邊個 H 係容易甩啦嘛。咁咪一 check 咧，我就乜都唔講啦，我淨係同你講，請你 check COOH 嗰個 H 就係啦。其餘啲 H 咁點啊？好渣，係咪唔容易甩嘅？嗱，留意啊，咁 OH 咧，阿 Sir，咁 OH 嗰啲 H 容易甩㗎，同 COOH 比咧，佢都係難啲甩嘅。咁所以咧，我哋就唔會考慮 OH 嗰個 H 嘅。一定要成嚿睇 COOH 金架度。嗱，遲下我哋講有機化學咧，我哋就會形容呢嚿嘢噶啦。咁呢嚿咧係好 reactive 嘅地方嚟嘅。OK， 好 reactive 嘅地方。咁啊，好 reactive 嘅地方咧，點 reactive 就話我哋話佢叫做官能基 functional group。我哋講緊係一個叫 reactive site 嘅地方，即係呢個有機化物入邊咧有化學反應嘅地方。咦？呢個 term 咁熟嘅，喺邊度聽過啊 ？reactive sites 係咪啲biology 啊？入邊有冇聽過啊？咁喺 enzyme 嗰度咧就會有就話俾你聽，成粒 molecule 咧係某一啲地方先有反應嘅啫。嗰個地方有反應嘅地方 reactive site 咯 ，reactive site、active site 係咪啊 ？OK， 做乜嘢問？冇嘅話，做冇啊？冇啊，講住咁多先喎。嗱，咁同學，翻去早做嗰啲 equations 啊，我發覺大家都好似唔係好搞得掂啊嚇，早做先。好，有咩講？冇就係咁先咯。再見啦，拜拜。
拜拜。
拜拜，拜拜，拜拜，拜拜，
拜拜，拜拜。
拜拜。